behavior, his or her experience or thought or action. Here we come to what is the earliest published psychological experiment by Americans, okay? A famous experiment by C.S. Peirce, who known to some of you as a philosopher, because that's what he was, and his graduate student, Joseph Jastrow, who was a pioneering American psychologist. And what Peirce and Jastrow did simply was to try to establish the question of whether there is a Lyman for conscious perception, whether there is a threshold for conscious perception, and if so, if subliminal stimuli could still make themselves felt on a person's experience. The procedure they used involved a psychophysical paradigm known as comparative judgments, and what happens there is that two weights are placed on sensitive skin, like the forearm here, and the subject's task is simply to judge whether the two weights differ in heaviness. Okay, two stimuli differ in weight. Or you can do this with visual stimuli. You present the person with two lights, and he or she simply has to make a judgment about whether they differ in brightness. It's a simple difference threshold kind of experiment. What Peirce and Jastrow did was to ask their subjects to assign a level of confidence in their judgments. So they'd say, yes, they're different, no, they're not, and then they'd be asked to rate how confident they were in their judgment. 100% confident, 50% confident, 0% confident, so forth. Then what they did was to gradually diminish the physical difference between the weights of the two stimuli, or between the intensities of the two lights, gradually bring those two stimuli closer and closer and closer together until there came a point where the subjects said, I can't tell anymore. I have no idea whether one of these is heavier than the other. I have no idea whether one of these lights is brighter than the other. At which point they said, okay, what we want you to do is just guess, okay, which one is heavier or which one is brighter. And the finding of the experiment is that even at zero confidence, still subjects were right more often than they were wrong, and that was a statistically significant difference. This is 1884. Peirce and Jastrow had to invent a bunch of statistical techniques for determining whether these were statistically significant effects or not. This is a great, groundbreaking experiment. So what you can see here is that this is the ratio of the weights. The weight experiment is the better of the two experiments for a variety of reasons. As the ratio of the two weights gradually diminishes closer and closer and closer to 1, the subject's confidence in their the judgments goes down, but the accuracy of their guesses still remains above chance. Here, where there's a relatively large ratio, then their guesses are correct about 100% of the time, 95% of the time, actually. Still, when they're down at 0 and these weights are really, really, really close together, still they're correct about 60% of the time, which is vastly better than you'd expect by chance. On the basis of this, the experiment and other experiments like it, Peirce and Jastrow concluded that, yeah, there is a Lyman, but it's a Lyman for conscious perception, okay? There may not be a Lyman for unconscious perception. And they influenced, they introduced this notion of subliminal perception into the scientific literature that we've had ever since. Just about as soon as Peirce and Jastrow published this paper, people jumped all over them, okay? And especially in the early 20th century, the criticisms began to mount and said, look, these are really, really, really hard experiments to do right. There are some problems with this idea that there are effects of subliminal stimuli. All of these, most of these criticisms revolve around what I've come to call the threshold bugaboo, okay? Which is to say, there are criticisms about how various investigators established the threshold for conscious perception. Because if it turns out that your threshold setting procedure isn't quite right, the stimulus that you think is subliminal might not actually be subliminal, okay? If you've just not done your method properly, then you're not going to get what you think you're getting. Think, for example, about how we define a threshold, say the absolute threshold. Remember from the lectures on introspection, a threshold is defined as the lowest intensity of stimulus that can be detected 50% of the time. That's how we define an absolute threshold. Wow! If it can be detected less than 50% of the time, it's still being detected some of the time. And if it's being detected some of the time, then it's not really subliminal, is it? Okay? It's something that's being detected just at a relatively low rate. So there are these kinds of criticisms, and we're going to see how various investigators have addressed them. And then there's the second set of criticisms that really crop up a little bit later, which have to do more with a theory or a theoretical bias about what you can accomplish pre-attentively. A subliminal stimulus, by definition, is a pre-attentive stimulus because you can't pay attention to something you don't see. You can't pay attention to something that you don't notice. So any kind of processing of a subliminal stimulus has to be performed pre-attentively. Now, you'll remember the old debate about the scope of pre-attentive processing. Is it limited just to the physical features of objects, or can it extend to the semantic features of objects as well? And then so some people said, of the person-Jastrow type experiments, okay, there's subliminal perception, but it's really not very interesting, because all you can do with a subliminal stimulus is extract some information about its physical features. You can't really get any meaning out of these subliminal stimuli. These criticisms then set the agenda for literally 100 years of research on subliminal perception. Okay, all of the studies over the ensuing century were intended either to address the threshold bugaboo, using more and more careful procedures for determining the threshold for perception, or to address this question about the scope of subliminal perception. Peirce and Jastrow and most of the earlier experimenters working on this problem used traditional psychophysical procedures which involved various kinds of, which involved presenting subjects with low-intensity stimuli, either very, very dim lights, for example, or very, very small differences between lights. That's another way of thinking about low intensity. These days, work on subliminal perception makes use of what's known as a masking paradigm, where you present the subject with a prime, for example, like doctor, okay, and then you do something to wipe that prime out of conscious perception. That's called masking the prime, and then you present it with a target that the subject has to do something with, in which case, say, for example, determine whether NURSE is a word or whatever your task might be. So what happens now is that the targets, the targets are presented superliminally. You can always see the target, nurse, okay? The prime is presented subliminally, but the subliminal presentation is caused by this masking procedure. If the mask were not there, the prime would be clearly perceptible to everybody. It's the mask that renders the prime invisible, if you will. So we've substituted these masked exposures for the weak exposures of the earlier kind of research. Here are just a couple of examples of masking. There are basically 4 kinds of masking that people use. Here, up in the upper left, is what's known as energy masking. You have the subject fixate on a target. And then you present basically a white screen, a flash of light. Then there is a presentation of the prime, like doctor. Then there's another flash of light. And then you present the target like nurse. And if you do it right, if you It's called the stimulus onset asynchrony, basically the time between the onset of the prime and the onset of the mask. If that is short enough, you never see the prime. You just can't see it, no matter how hard you try, okay? And then the question is, does this presentation of this masked prime affect the processing of the target? Or you can use another favorite procedure, it's called backward masking. Subject fixates, you present the prime, then you present an actual stimulus, like a bunch of hash marks or some kind of noisy pattern or whatever, and then you present the target. And again, if the stimulus onset asynchrony, the SOA, the interval between the onset of the prime and the onset of the mask is short enough, you never see the prime. Here is forward masking. You can do it in the forward way as well. The person fixates. Then there's a presentation of the mask, presentation of the prime, a blank field, and then a presentation of the target. Again, if the SOA is short enough, you never see the prime, even though the mask comes before the prime. I know, it's weird, but it's true, okay? And then finally, you can pull out all the stops, right? Taking no chances, you can present a forward mask, then the prime, then a backward mask, and then the target. If you do these experiments right, and they're not hard to do right now, we know how to do them, the SOAs are very, very, very short, on the order of 17 milliseconds, 34 milliseconds, 68 milliseconds. If you're doing the math, that's about the rate at which a screen refreshes itself, the cathode ray tube refreshes itself. You can get these masking effects so that the prime is literally invisible. Nobody can see them, okay? The only person I know who can reliably see a masked prime is a woman who's been serving as her, in her husband's experiments using masked priming for about 30 years. She is unbelievably good at this. She's very, very, very used to this kind of procedure. And she can sometimes detect these primes. I've never seen anybody else who can do this. Okay, so what do we do? Here's an experiment, a famous experiment by Anthony Marcel, Tony Marcel, then at Cambridge University, on masked semantic priming. What Marcel did was to present primes like doctor, followed by a mask, followed by a target like nurse, and the subject's task is simply to say whether nurse is a legal English word or not. It's a straightforward lexical decision task, and we're looking at priming effects. And here we have one of Marcel's experiments, and we're looking at the response latency. We're measuring priming by response latency. If there is priming, then people should be faster to identify the target as a legal English word. Okay? So seeing doctor does create a priming effect on lexical decisions about nurse. The question is, if you mask the word doctor so that you can't actually see it, do you still get the priming effect? And the short story is yes, okay? That in each of these instances, whether the prime is repeated just once or even as many as 20 times, you're getting this significant priming effect so that if the target and if the prime and the target are associatively related or conceptually related, you get a priming effect. If they're not, you don't get a priming effect. That's semantic priming. It's a priming effect that has to be mediated by the